Hey Twitch, hope you're having a great weekend, and yeah, I'm having a good weekend. Learning over the weeks as I'm streaming that Twitch Studio lies. So yeah, it turns out you can have your microphone muted in Twitch Studio and it still gets captured or broadcasted anyway. So that was fun to see. So let me see here if my scenes are still working. I gotta update my, I don't know why this happens, my camera kind of disconnects or something. So yeah, I had to mute my microphone from a different place. Slightly annoying, but you know, it is what it is. So yeah, I actually officially got word yesterday that my talk for ElixirConf was accepted. So that's at the end of August, leading into September. So looking forward to that. So again, my talk is WebAuthn with LiveView. And so I've started, well, last week on my live stream, I kind of outlined the kind of the points I would want to hit on the talk. And yesterday, I wasn't live streaming, but just spent a little bit of time kind of putting together some slides and kind of going through the motions, getting an idea of how I might want to kind of lay out the presentation, kind of how I want to order things. As well. So let me adjust the lights a little bit here, and then I'll show you kind of what I've got. I'll give you a sneak peek. I probably won't go through all the slides here, but there was a recent update to Keynote, so there's some cool stuff you can do now. So let's take a look. So at least for now, I'm using Keynote. I think last week I may have also looked at stuff like SlideDev, which would be more like a Markdown, like a more developer-oriented version of putting together slides, and that might give me more like control and flexibility. Like I can imagine a lot of ways to make a really cool presentation, but they're kind of hard. You can kind of get it to work in Keynote. Like I had a video background that could play through all the slides, and it worked, but when it was supposed to loop, it would just kind of stop playing. But anyway, that's probably not a huge deal. Keynote has dynamic backgrounds now, so these are, I don't think they're video. I think they're probably something like SVG or something maybe even more low level than that. That's kind of rendered by Keynote. And so these backgrounds, they're animated, and you can, so I think this is at its fastest pace, but you can kind of adjust the appearance of your background. You can adjust the colors. You've got a few sliders here for how fast and which direction everything moves. You can customize things quite a bit here, and they have a handful of pre-made dynamic backgrounds. Pardon me. And these are really cool, but this is the one I think I'm going to use for my talk. I've kind of tweaked this to kind of fit. It takes a little bit of the orange from the Phoenix framework, a little bit of purple or fuchsia maybe from Elixir Space, or also I have some very similar shade with the stuff I'm doing in Live Showy. So yeah, this is kind of where I've started with the presentation, and so I've got a handful of slides built so far. If I talk through the slides that I have without actually like putting together the demo or the code pieces, it's only 15 minutes maybe. So I have a lot left to write. Probably will have, it's only got 9 slides right now. And so that will not include code. I think that's going to happen in probably Livebook or maybe VS Code. And then demos will happen just in the browser. So I am expecting to either point people to LiveShowy or maybe a separate app dedicated just for demonstrating WebAuthn. So that may just be kind of more of a toy app that I release just for this talk, or that I deploy for the talk. And that way people can go to like just a kind of a testing application for connecting WebAuthn. I don't know. I kind of go back and forth on that because I don't want to spin up an entire app and have to maintain it and everything just for demonstrating WebAuthn, especially for a long period of time, because like I don't want to have to build out other features like that I could just be building into LiveShowy. So anyway, that's kind of the high level plan here. So I've kind of built up some slides, added a little bit more detail from the markdown outline that I'd worked on last week. So I've got a short history of passwords, very short history, glossing over a lot of innovation in the password space. But the whole idea with this talk is about WebAuthn, so I don't want to spend too much time in the weeds of passwords, algorithms, changes over the years and that kind of thing. I just want to kind of acknowledge that passwords have gotten us this far, but it's time to move into something a little bit more modern and more secure. So then I'll be talking about WebAuthn, explaining kind of at a high level what it is, what it can do and how it can be used, and the new things that are coming along like passkeys that already supported in Android, coming to iOS, I think by the end of the year with the next version of iOS. And then just this past week or two, I think, maybe a few weeks ago, they announced it, but I saw it a week or two ago that 1Password has announced that they joined the FIDO organization. So that's the organization that kind of created or like was responsible for kind of led to research that, or did research that led to the development of the Web Authentication Api. And they continue to kind of push the envelope on how to securely authenticate users with their identity. And I even heard on the Random But Memorable podcast by 1Password, they mentioned a new, I don't know if it's a spec or a new initiative. I think it was called DID, Distributed Identity. I think there's like there's efforts on like a more robust identity technology. I think it's the name Tim Berners-Lee was involved in some way with that. So that's years like into the future for us to be able to use it, but it sounds like there's some really great, like that's been one concern that I've heard raised by people, and I've kind of registered that as like if like basically there's no way to really know who you're talking to or like who your user is on your application, or like once someone's authenticated, like now we have web authentication that's going to help us, but like identification or identity is kind of an even larger problem that kind of needs to be solved. Maybe not something for every application to take advantage of, but you can think of like sensitive, very highly sensitive applications like anything with banking or healthcare, where it's really important that whenever the bank teller describes your account, that they're actually talking to you and not someone impersonating you. So that could be over the phone or online. So hopefully there will be a lot of great innovations coming out of that initiative. Back to the slideshow, there will be a demo section. And when I talked at Big Elixir, my demo was very early in the talk. I may move these slides around a little bit. I may kind of move the demo. I think I want to have the demo twice. I want to have demo where you use WebAuthn without necessarily understanding how it's working and what's going on there, and then do the big talk, look at code, and then come back and go through the demo again, where like you would see it again at the end, and then you'd have a better understanding of how it works. So I may kind of do the demo twice. We'll kind of see how that goes. I'll be talking about like shopping for solutions. Like it's great that we don't, like there are a couple of packages in the Hex or in the Elixir ecosystem. So the Hex platform and the package management system. So Wax is the one I'm using. It's the most robust, the best documented package for WebAuthn stuff. So that's the one I'm using. There are a couple of others, and then Cbor is actually another library that's used by at least the Wax package for. I just saw the acronym earlier. It was consistent binary object. No, I had to look up what Cbor stands for again. But anyway, then we'll talk about the Web Authentication Api. It's not like you don't need to install any kind of NPM or Node package on a Phoenix app in order to take advantage of this. Basically, you need some server-side technology. You can write it yourself. I don't know. I may revisit whether I want to start rewriting like my own WebAuthn stuff, but there's already a couple people tackling that, and like I said, Wax already it's working, so I may not necessarily need to spend time reinventing the wheel if that's already in the world. So yeah, but on the client side, you don't necessarily need to install any kind of JavaScript packages because this is an API that's built into the browser, and as long as you're using one of these browsers, basically anything that's not Internet Explorer, and as long as you're up to date on your version, then you're good as far as the user goes. And then I'll talk about how interacting with WebAuthn over LiveView is a little bit different from interacting with it through a controller, through a traditional HTTP request and that kind of thing. So I'll be tweaking this slide a little bit. I'll be showing code, and I think that's what I want to spend most of the time on today is figuring out how I want to structure. Like I think what I want to do for this piece, for the code, is I want to use LiveBook. Now that I've got I've got a couple of hours using LiveBook under my belt now, so let's take a look at that. I do have to remember how to run LiveBook, I think. Hang on just a minute here. Okay, so it's running. Oh, I've got to get the token from the terminal. And I just remembered, I usually like to use a touchpad while I'm live streaming, so there's not all these extra click noises. So I think I'm going to go ahead and switch things out a little bit here. That's the crazy thing. I haven't really used a mouse in a while. It's been a few months. So I started using this one just to see if it would help with a little bit of wrist pain. I think this little beanbag pouch thing actually helps more with that. The mouse is actually nice. But the touchpad, I think, is a little bit more stream friendly. So let's see here. There we go. All right, so here is my markdown outline. I probably don't need to keep this particular piece open. Okay, come back to the code later. I do believe I have, let's see, did I actually do, I thought I had a notebook in here. Maybe I didn't save anything. That's fine. Okay, then I'll just start a new one. Yeah, I don't think I really actually had much going on in here before. So now I can add a package. We're going to add wax. And that should allow me to do stuff like wax dot okay, so I need to run setup before I can use those. Okay, very good. So now I can do wax dot. So we'll take a look at new registration challenge first. Let's just see what happens if we have no options there. Okay, so we need some options. I'm going to open up the code that I already have. Okay, so I'm going to give this some options. So we're going to go with attestation none. We're going to go with RP. I'm not even sure what other options I actually need to pass in here. Origin. Okay, origin. And then I think I've got in my code, I have a helper. Somewhere. It must be in, is it in my LiveView? View helpers. Oh, it's probably in helpers. Okay. A little bit of a goose chase there. So if it's in dev, it uses the socket host URI. I don't have the socket here in Livebook. I can double check that here in a moment. Otherwise, it goes to the endpoint URL. I think I'm just going to say localhost, and we'll see if this works. Okay, it must be either HTTPS scheme or localhost. Okay, maybe this needs to be. Okay. I think auto, was it Adam? There we go. So I'm going to save this in the ElixirConf. Okay. Okay, so down here it actually adds the LiveMD extension. So that's good, that's perfect, that's what I need. And I think, yes, I do want to save it every 5 seconds. Okay, so this is what I did not do last time, is I didn't actually have it saving the file. Cool. All right, so now this will actually be persisted. So this will be the WebAuthn registration challenge. I think here I need to add, I think I want to add a description of what a challenge is. I wonder where I can get the best description of a challenge. All right, I may take this. I'm going to take a look at the spec and see if it's too dense or just dense enough. Challenge of the authenticator signs along with other data when producing an attestation object for the newly created credential. That is as dry as could be. I think I'm gonna use this quote from the WebAuthn guide. All right, let's see. Did I get that right? WebAuthn.guide. Okay. So that looks good. Challenge is a buffer of cryptographically random bytes generated on the server and is needed to prevent replay attacks. Yeah, I think I need to probably explain some of the terms, because otherwise there will just be a bunch of terms that flying around and no one's going to understand what any of this means. Let's see, so a challenge, I think I need to explain, I think I need to break out registration as well. Actually, this whole section probably needs to go somewhere else. That's better. Okay. So we'll say registration. Should this be a table? I wonder if this, so in VS Code, it's really cool when you use markdown tables. It will automatically kind of pad each of the rows and like format them nicely in the code. I kind of wonder if that's going to happen whenever I start filling this in here. Like I'm not seeing it, like it would add like as many hyphens as it would need to make these, you know, equal width, I think. There we go. So let's talk about registration. And That one I can define reasonably well. How do they define? So there's wax new registration challenge, then there's wax.new authentication challenge. Okay. So I think the other piece here would be authentication. How do you define a word without using it in the definition? So I don't want to say authenticate a user. I want to say so when we talk about registration, we're talking about creating a new user account. When we talk about authentication, we're talking about verifying a user's identity. That's kind of loaded, but I think that's going to be okay for now. So then we have a challenge. And a challenge, let's see, I think I can paraphrase what they say here. It's a buffer of cryptographically random bytes generated on the server. I mean, doesn't really get more explicit than that. Okay, and then what's the next piece here? RP. I don't want to explain all the terms, so I'll try to explain just the pieces of information that we're seeing in the actual code. I guess some of this will show up in the challenge as well. Actually, these definitions might be better in the actual slideshow itself. Because I think whenever I'm presenting a list or even a table of information, I try to present just one piece at a time and not the whole thing, because it's really easy for the audience to kind of start reading ahead and not hearing what you're saying. And I don't read word for word what's on the screen in most cases. So that can get really confusing, or I might be trying to say something important that people are missing if they're reading several lines ahead. So I think instead of doing this in a markdown table here, which admittedly looks nice, I really like what I'm seeing here, I think I'm just going to do this in Keynote. Of course, first and foremost, we have to have some kind of icon here. What makes sense for terms? I need books or something. I think that'll work. So anything else? Well, I think we'll stick with the book. That can always change if we need to. This should have a black fill. This goes in, and then I think it animates in with a spin. Top to bottom. Okay. So now I can insert a table. Okay. I don't need 4 columns, that's for sure. Okay, I do want to expand this somehow. Okay. These cells are huge. All right, so the first one is registration. Then I've got create a new user account. That should be bold. All right, then I've got authentication. Verify a user's identity. Then we've got a challenge. It's a buffer of cryptographically random bytes generated on the server, and this prevents replay attacks. I think I'm going to make sure that yeah, generated on the server is the key point there. We also have an attestation. There's actually there's attestation data, which comes back from the I think from the. So there's a distinction between this attestation key and then the attestation data that comes back from whenever you generate your WebAuthn challenge. So I need to maybe find a better explanation of that. Authn attestation. I want to find the distinction between attestation and assertion. Okay, so when an authenticator registers a new key pair with a service, the authenticator signs the public key with an attestation certificate. The attestation certificate is built into the authenticator during manufacturing time and is specific to a device model, that is, all Samsung Galaxy S8 phones manufactured at a specific time or particular manufacturing run have the same attestation certificate. That's interesting. So it's returned through the WebAuthn API as the Authenticator attestation response. The attestation format contains 2 basic array buffers, the client data JSON, which is an array buffer that contains a JSON representation of what the browser saw when being asked to authenticate, and an attestation object, which is that cryptographic attestation that a newly generated key pair was created by that authenticator, contains authenticator data and an attestation statement. Oh, God. Wow. Attestation. Oh, my God. This is going to be hard to explain in a talk. The authenticator data contains an attested credential data field. The attested credential data field contains the credential ID and the credential public key. The authenticator data is the same structure that is used in the authenticator assertion response. The attestation or the attested credential data is an optional field used in attestation. It's not included when used in the Authenticator assertion response. Okay. See, it's easy. Different devices have different attestation formats. So there are different formats for attestation. I think I currently have been using, so whenever I'm generating the registration challenge, I'm using attestation none. I think that's because it was maybe a little bit of trial and error. I was having trouble initially getting, I think this comes from Safari. I think it was working with Attestation Direct in Chrome, but then in Safari, it wasn't working until I put attestation none. But that could have been a misunderstanding on my part, and I want to make sure I get this right. So, like if I'm giving a talk, I definitely need to make sure, I need to check my assumptions and make sure I'm presenting correct information. So I'm going to take a quick look here at the login and see what that challenge looks like. So it also has attestation none. So like TPM, what are my options in Wax? I wonder, why do I have two Wax tabs open? Okay, so direct. So I have two options, at least within Wax. I can use none or direct. I don't know what that means. So default is none. And trusted attestation types. Okay, so there are basic, self, at CA, which I think is Attestation Certificate Authority, ECDAA, don't know that one, uncertain, and none. That's the attestation types. This word seems overloaded. It might make more sense later as I've worked more deeply with this. But attestation is used in to mean a few different things here. The purpose of attestation is to cryptographically prove that a newly generated key pair came from a specific device. This provides a root of trust for a newly generated key pair, as well as being able to identify the attributes of a device being used, like how the private key is protected, if what kind of biometric is being used, whether a device has been certified, etc. It should be noted that while attestation provides the capability for a root of trust, validating the root of trust is frequently not necessary when registering an authenticator for a new account. Typically, a trust on first use model applies. That's a tofu model. Nice. And when adding an authenticator to an existing account, a user has already been authenticated and has established a secure session. I can understand what they're saying there. The tricky piece is, like, so in the MDN docs, I'm seeing these different attestation formats from different devices. I don't know how this applies to, or I guess it doesn't really apply. So like any of these devices can be used to generate an attestation. And I guess Wax would just be able to support any of these devices, but it's not like these Yeah, I think I'm going to try direct. I wonder if there's any. Let me see what the docs here have to say about attestation. Okay, so what it was saying there in the MDN docs was you could verify trust root, but it's typically not necessary. Now, it's actually enabled by default in WAX. The MDN docs were saying that's not necessary, but I think if it's like a more secure option to have it enabled, and it's enabled by default, and it's been working, then I think I'm going to leave it enabled. I wonder if I have special config for WAX. Okay, so these are the allowed attestation types that I have for this app. So it allows basic, uncertain, attestation, certificate authority, and then self. Oh, I've already got that set and config. I may not need RPID auto here, but that's not super important at the moment. Okay. So back to the slideshow. How do I explain attestation? So here I've got it set to none. Oh, right, I've got LiveBook open, so I can just kind of see what the difference is whenever I run this with none or with direct. First of all, what do we see in here? Attestation none, so that's where it shows up. Okay, so now let's try direct. I think the only thing that's going to happen is we're going to see, yeah, direct shows up here. User verification preferred. I think these all appear to be the same. Preferred, true. Okay. And these are the bytes that are going to be used in the JavaScript to generate the attestation data. So the client data, JSON, and all that stuff that gets sent back to the server. Oh, and by the way, if you're watching, chat's open. You can always drop in questions or just say hey. And absolutely, if you're going to ElixirConf, let me know. All right, so how do I explain an attestation? I think I'll explain it as the data that comes back. So, buddy. Okay. Okay, this makes a little bit more sense. So the attestation key that I've been updating here from none to direct, or I guess indirect would be another option. So just reading this a little bit more thoroughly here. So the attestation data that is returned from the authenticator has information that could be used to track users. This option allows servers to indicate how important the attestation data is to this registration event. A value of none indicates that the server does not care about attestation. A value of indirect means that the server will allow for anonymized attestation data. And then direct means that the server wishes to receive the attestation data from the authenticator. So I wonder what this means could be used to track users. Okay, so these are attestation types. Basic, self. So I've been using none. I guess direct would fall under just one of these others. So basic. Yeah. In the case of basic attestation, the authenticator's attestation key pair is specific to an authenticator model, i.e. a batch of authenticators. Thus, authenticators of the same or similar model often share the same attestation key pair. Ooh. Model. Self, okay, so in the case of self-attestation, also known as surrogate basic attestation, the authenticator does not have any specific attestation key pair. Instead, it uses the credential private key to create the attestation signature. Authenticators without meaningful protection measures for an attestation private key typically use this attestation type. Authenticators without meaningful protection measures. And then attestation CA. At CA. In this case, an authenticator is based on a trusted platform module and holds an authenticator-specific endorsement key. This key is used to securely communicate with the trusted third party, the attestation CA, formerly known as the privacy CA. The authenticator can generate multiple attestation identity key pairs and requests an attestation CA to issue an AIK for each. Using this approach, such an authenticator can limit the exposure of the EK, which is a global correlation handle to attestation. Let me read that one more time. Using this approach, such an authenticator can limit the exposure of the EK, which is a global correlation handle, to attestation CAs. AIKs can be requested for each authenticator-generated public key credential individually and conveyed to relying parties as attestation certificates. So there may be multiple certificates. So for live showy attestation, or I guess user tracking is really not a concern. It's not something I really need or want to do. So I'm going to leave this as none. I wonder if I can move that into config. I don't have that running, so I'm not going to make a bunch of changes right now. I wonder if direct shows up in here somewhere. All right, I do want to pause and read here about security considerations. So this specification defines a web API and a cryptographic peer entity authentication protocol. This will make sense. The Web Authentication Api allows web developers, i.e. authors, to utilize the Web Authentication protocol in their registration and authentication ceremonies. The entities comprising the Web Authentication protocol endpoints are user-controlled WebAuthn authenticators and a WebAuthn relying party's computing environment hosting the relying party's web application. In this model, the user agent together with the WebAuthn client comprise an intermediary between authenticators and relying parties. Additionally, authenticators can attest to relying parties as to their provenance. I think we need to define relying party. So the relying party is the entity whose web application utilizes the API to register and authenticate users. So this is the, how do I want to say this? Like the application or the business that runs the application. Owner of the web application. I don't think these are necessarily going to be complete sentences. Okay, so that I think works. At this time, the specification does not feature detailed security considerations. However, the FIDO security reference document provides a security analysis which is overall applicable to the specification. Also, this other document suite provides useful information about authenticator security characteristics. The below subsections comprise the current web authentication specific security considerations. They are divided by audience. General security considerations are direct subsections of this section, while security considerations specifically for authenticator, client, and relying party implementers are grouped into respective subsections. So the Authenticator, I wonder if MDN has a little bit more friendly verbiage here. Okay, so the Authenticator is the device that so the Authenticator is the device used to create and store credentials. Let's see, how do they define relying party here? Server. Well, I've already got that covered. Oh, that closed. MDN. Let's go back. All right, so client. Let's see, how do they define client? I mean, I guess client is just, in this case, it's going to be the browser. Do they have like a super clear definition of client here? Wow, 726 references to client. Yowza. Let's go all the way to the top and see if maybe got a good one in here. WebAuthn client. So client is like the browser and like user. I think that makes sense. So in this context, the client is actually the browser used to request credentials from an authenticator. I think that works. Attestation. Let's see one more time if there's a clear explanation. Again, 500, 600 references to attestation in this document. I wonder if you printed this out, how many pages it would be. I'm going to go command up. Oh, a lot of these are from the sidebar. Okay, so attestations. Let's see. Should also provide some attestation if possible. So it's a statement that serves to bear witness, confirm, or authenticate. In the WebAuthn context, attestation is employed to provide verifiable evidence as to the origin of an authenticator and the data it emits. This includes things such as credential IDs, credential key pairs, signature counters. An attestation statement is provided with an attestation object during registration ceremony. See also blah, blah, blah. whether or how the client conveys the attestation portion of this. Okay. Provides, I'm trying to like paraphrase this into like human language. Let's go back here and see what MDN has to say about attestation. Okay, yeah, the MDN docs are a little bit clearer when it comes to this. So I think what I'll say here is it provides a signed public key for to be used in future authentication requests or attempts. I think that'll work. So are there any other terms I really need to add here? Authentication. I guess assertion. So the assertion, let's see, maybe there's a clear explanation here. Okay, so when a user chooses to log into a service, the server sends a challenge and the authenticator signs over it with a key pair previously registered to that service. This creates an assertion. I really need to open that in a separate tab. So authentication, so this piece here matches rolling party ID and prompts user consent authentication. Size full. So this is a signature used, created by the authenticator upon identification and user consent, I think. Okay, I think that makes sense. All right, let me tweak this table just a little bit. Don't really need an outline, I don't think. I think I want the text to be left aligned, or maybe right aligned here. Do I really need? I don't think I need that first row. And then everything can align to the top. Okay. Now I think these can animate in one row at a time. So these have been what, spinning? We're gonna go top to bottom by row. What's up with that row? Challenge. It does look a little bit wonky having the terms right aligned, and yeah, it's kind of weird having the table centered, but yeah, I think I'm gonna move this over to the left. I'm gonna figure out what's going on with that row. Maybe just this table needs to be expanded a little bit. Replay tags. Okay, so that's what it's missing. I think I'm gonna just remove that particular phrase and then adjust things back a little bit here. Okay, I think that works. Let's see if it looks the way it should. I gotta fix a couple of animations here. Where is border? Oh, there it is. Build order. Okay, so this should go automatically after the transition. This should go after the icon animates. Okay, and then everything else should be toggled by clicks. Okay. So the first term will be registration, which is about creating a new user account. Authentication is about verifying a user's identity. I think that should be an existing user's identity, just to be explicit. The challenge is a buffer of cryptographically random bytes generated on the server. Attestation provides a signed public key to be used in future authentication requests. An assertion is a signature created by the authenticator upon successful identification and user consent. Relying party is the owner of the web application. The authenticator is the device used to create and store credentials. And the client is the browser used to request credentials from an authenticator. So I think here I'm going to add examples of YubiKey, Touch, ID, I think that's one word, Face ID, Windows, Hello, might even be an option there. Okay. Oops, that should be bold. Okay. Uno momento here. Oh, and I'll do that tomorrow. I'll say it'll give me a reminder. Tomorrow. Okay. Sorry, distractions. Okay. I think that's a good roundup of terms without going to college to understand everything about WebAuthn. I think that will be just fine. Okay, so then after that, I think the demo probably could come in right after. I think that should be first thing after introduction, actually. Okay. Okay, so let's imagine I'm going to do a fast forward version of this. Hello everyone at ElixirConf in this room or from the stage. Today I'm here to talk about WebAuthn, LiveView, yada yada yada, passwordless future, applause applause. Then I'm Owen Bickford. I'm a real-time application lover. I really do love real-time applications. Web security enthusiast does not mean I'm an expert. And my path to Elixir looks a little bit like this. And I love a demo, so we're going to start with a demo. And this will be where we look at live showy. So we're going to sign in with what is today? I like to date these things. 0617. All right. So I will maybe have people pointed to live showy, or maybe oh wait a minute. Do I have this connected to my .com? Not yet. Okay. Yeah, the .com is a little bit outdated at the moment. Okay, so sign up. I'll select security key or this device. I need to add an Android phone. Okay. It's going to identify with liveshowy.fly.dev, which is currently the web URL. Got this device. That will ask me for a fingerprint. So I guess I'll go ahead and do that here. Takes me to the settings. I'm already an active user. If I log out, I can come back and then I can go 061722. It will ask me for the password again. Sign back in. Cool. All right, yay, that demo was a success. Where is Keynote? There we go. So then that was a fun demo. Nothing really actually did go down in flames. All right, so this will be audience participation. I'll just ask a bunch of questions about passwords. I may not ask, I may edit this down a little bit. But I kind of want to want to get people into the mode of thinking about passwords, how we struggle with passwords, and also kind of get an understanding of where the audience is at in their understanding of WebAuthn, if they've even heard of WebAuthn or passwordless authentication. It's a developer conference, so I'm pretty sure that there will be people in the audience who are fully aware of this. We'll take a quick look at brief history of passwords. Yada, yada, yada. We'll meet WebAuthn. At like a high level. I will kind of harp on the thought here that it can actually be used to replace passwords. Like that's what I'm doing with LiveView. And cool stuff happening with iOS and 1Password. Then we'll talk about the terms. So registration is where you create a new account for a user. Authentication is where you verify an existing user's identity. Challenge is the cryptographically random bytes generated by the server. Attestation provides public key to be used in future authentication requests. Assertion is a signature created by the authenticator upon successful identification and user consent. Relying party is the owner of the web app. Authenticator is the device used to create and store credentials. Client is the browser used to request credentials from the authenticator. Then we'll talk about hex packages, so on and so forth. Then we'll talk about differences between controllers and HTTP requests compared to LiveView and WebSockets. Then we'll look at the code, which would be here. Okay, so I think so far so good. I think I'm going to stick with a none attestation because I think within Livebook I'm not going to. Yeah, I need to read some docs on Livebook and see if Phoenix LiveView hooks, like the JavaScript hooks, can be used in Livebook. I'm not really sure if they can. I would kind of doubt it, but I could be pleasantly surprised. But that's okay. We can kind of still look at the components of data. I can maybe use a security key that I don't want to actually use and then show credentials generated from that. I can at least put in another section here for the authentication challenge. And then for opts, I think let's take a look at the VS Code again. So in login, this would be the authentication. The only options I have here are attestation none and origin. So let's see, where'd it go? Attestation none. And then origin. Actually need to, let's see, new authentication challenge, ops. Ooh, okay, so here, So before I get to this step, I actually need to create, like I actually need to complete this step and like get an actual like a key ID and public key, so that can be passed into so in the code, this is what I'm looking at. So basically I need a list, or I guess a map of key IDs and their public keys. And that would be the first argument here. So for now, I'm going to add like a placeholder. All right, let's see if it works at all with an empty map. Nope. Oh, I guess I've got to give it RPID. Okay, that works. So it generates a challenge, but it's not going to actually allow anyone to use it because this challenge does not allow actually any credentials. So that would be a problem if it was really being used here. But in the actual app, so we're basically pulling the user with their username and then getting their user keys. Let's see. So whenever the user submits the login form, we're taking whatever username they provided, attempting to get a user. If we don't get a user, we show an error message. Otherwise, we will get that user with their user keys. We will take all those user keys, put them into a map, or into a list of tuples, which I guess could be also a map. But each key ID is the first element, and then the public key is the second element. And then that gets passed into new authentication challenge. All right, now I'm going to take a quick break here. So I'm going to get some more tea, do some break stuff, and then I will come back. This will take maybe 5 minutes, if that. But I'll be back here in a moment, and I think we'll spend at least another 30 minutes. I will go until 4 o'clock Eastern time to wrap up today's live stream. And so yeah, stick around. welcome back. All right, so hope you had a fun little break there. Sure did. So yeah, let's go ahead and wrap up with the last half hour here on the live stream. So I guess I could start sharing my screen again. So we've got a registration challenge. We have an authentication challenge, which wouldn't actually allow you to log in, but that's okay for now. And you'll see that these actually look quite similar. Of course, the bytes that are generated are random, so these are not consistent. Every time you call this, you're going to get a different result. Actually, since this is a saved live book, if I restore it, it will, I think the results are stored. You can actually copy things out of live book, which is pretty handy. Especially if you're like running IEX, you could just copy this directly out and paste it there, and that would be, could be helpful. Let's see. Format code. Oh, amplify output. That's cool. Okay. Let's see. What else do I want to cover here? Okay, so I think I'll just add a note to myself. To do. I think this has to be a H3 or smaller. To do. All caps. Drop in an example WebAuthn. What do we call, like, I want to say client response, but what do we actually call that? Authenticator creates an assertion. Authenticator returns data to browser. So when you're in registration, okay, so I think I called this registration credentials. I think that will work here as well. Drop in example, registration credentials. I guess determine if JavaScript hooks can be called from a live hook. All right, that's good. And then I'll add another to-do block here. Toto. Update allowed credentials with, ooh. Ooh. Excuse me. Update allowed credentials with example key ID and public key. I think that'll work. And then actually I could probably kind of fake that with what I have already. So let me open up Postico. I'm not going to show it on screen though. I'm going to run a couple of commands here. I'm going to keep opening all the wrong windows. So off screen, let me run. So I have the live showy kind of like pre-alpha hosted, but I've got to open a proxy so I can access the database there. I just want to make sure I haven't opened Pandora's box in some way. But I've got so many commands in my history. Okay. I'm just scrolling through terminal history here, trying to find my fly commands. Some of these commands I'm seeing, I know I did not run, and this is off screen, by the way, you're not going to see it, but I see some commands I haven't run in like 4 months. So I must be way, way back in history. Way, 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 way back. There's got to be a way where you can like reset where you are in your terminal history. If you're using Z shell or something. I would actually go and check, but then I'd have to stop scrolling. But it's okay, I think I'm getting closer here. Or maybe farther away. I really cannot tell anymore. Or I could just, you know what? I could just pull up the docs. Fly. Oh. There we go. Okay. Connect, connect, connect. All right, all right, all right. Right, okay, so I was going to open up the database and copy like the key ID and public key out, but the problem is they're binary and yeah, they basically need to be base. They need to be base 64 encoded to send into the browser. So I'm going to do that. I've got to start my local server here, so that's going to be IEX mix phoenix.server. Get user by user. User keys. Sweet. Okay. Okay, so I've got a couple of IDs and public keys I can use. I think I'll just kind of take the abbreviated version of what I've got here so that I can encode it. Base encode. I think it's got to be URL encoded. Let me see here. Oh, I guess I've just been using encode. Encode 64. Let me check that here. Base 64 encode. Okay, base 64 encode. Again, I'm doing this off screen because it does involve security keys. I don't think you would be able to do anything with it, but I just don't want to be wrong and find out the wrong way. Okay. Oh, yep, I copied the wrong pieces of data, I think. Let me try this one more time before I stop. Okay. Okay. I think I'm going to leave this as it is for now. I need to work later on getting like an example key that's not associated with anything. I mean, really. So I think my understanding is that even if the public key in the database was breached, so if someone had that public key, they wouldn't be able to do anything with it because it needs to be used from the server that hosted the key in the first place. Or from the server where the authenticator generated the key. But I just don't want to take any chances or find out that I misunderstood how this works. So that's why I'm going to leave this allowed credentials blank for the moment. Let's see, is there anything else I want to tackle here, or at least within the slideshow? I think I may need to at least give myself an outline of what I want to do in the code, like what I want to show in the code. So I think I'll show sign up, which is the registration flow. And this will be where we take a look at the form submission, which generates a challenge. We'll look at the JavaScript hook, which creates the ID. I'll leave that later. So form submission which creates the challenge. We'll look at the JavaScript hook, and then we will look at the registration credentials, event handler. Actually, I should probably make this more explicit as well. Submit event handler. Let's see, which JavaScript hooks do I need to look at? WebAuthn. So this would be the function. I'm going to do some folding here. Clear token, token mounted. Okay. By the way, as I'm kind of refreshing my memory on WebAuthn, some of the things I did here may need to be modified, as I understand things a little bit more in depth than I did when I was kind of building this up for the, a few months ago. So this will be an event listener for, so WebAuthn JS 147. And then, so that's 147. Then we'll look at the function that actually, so then 14. Which actually pushes the event back to the server. Actually, I think we'll start with 134. Okay, I think that's a good place to start and then leave off there. And then we'll look at the registration credentials event handler. And then, let's see, would we want to look at the database? Sure. So we'll look at the results of getting the username. We'll look at the post-to-co. So we'll kind of look at how the data actually looks in the database. Then we'll take a look at the log and authentication flow. So this will be another submit handler. We'll look at WebAuthn.js. Which lines? This will be login challenge. So that'll be 152. Then 67. Then we will look at the authenticate event handler. Is there anything else we would need to look at? I think that'll be good for this point, for this slide. All right, so that'll be code. I think we will maybe go back into straight into the demo after the code. I think this, if I were to like run through this, like actually read all this, like run through all the slides. I started on it yesterday, so like it's light on content so far, but it'd probably take 15 minutes, I think, at most to get through all this. And that would be, so if I'm kind of on the fence, like do I want to try a quick, like brief run through today as a sneak preview, or do I want to hold out for for later. We shall see. I think I'll remove the fire animation from the demo because I think this one's going to be just fine, at least at the end. And I don't want to be too hard on myself. Once I've gotten to the last demo, it should be smooth sailing. So how do I want to represent that? I wonder if there's like a bow. Can we kind of put a bow on this? But it's not really gift. These shapes in Keynote are, it's kind of funny. You can actually kind of combine these and do some funny stuff. What do I want to use? This is like this is how you spend most of your time when you're doing a talk. You spend a lot of time, is this yak shaving? Like just finding icons, messing with the colors and the backgrounds and everything in the fonts. At least that's how I do it. I know some people are pretty bare bones in their slideshows. Not me. I think I might use one of those check mark icons. All right, I will probably update this again later, so it doesn't extremely matter. Let's just dump this in here. How big is that? Good enough. For now anyway. We get that shadow in there. Oh, 06100. There we go. All right, so do code, which will be livebook. Don't want to forget livebook. I think I'll just leave it like that for now, and then demo. We'll do demo one more time. And then how do I want to? What just happened? Okay. How do I want to round this out? So I might just kind of revisit this slide. I do think like it'd be nice to kind of reference the slide without having to like duplicate it. I don't think that's something you can do in Keynote. Let's see. Let's do a blank one. Can I reference another slide? Nope. Okay, I don't think so. So this will just kind of reinforce what we covered. So there's a recapping. And then gotta have like a where to find me slide, right? I got thank you or something. So this would be we'll call that a thank you, and then get rid of that. All right. Oh yeah, Twitch. Gotta mention Twitch. How would I be at a conference after this live stream and not even mention Twitch? All right. All right, so these slides will change a little bit before the conference. I do expect that I'll have like a trial run, maybe with a meetup or something, or maybe at work. For this. But I think it wouldn't hurt to kind of do a very extremely rough run through here. Let me get some of these things closed out. Close Livebook. Close Wax. Reopen most of those later. I don't want to forget about this one, so I'm going to save that for later. Okay. All right, so let me kick this off. Let me use window mode for this, so it's easier to switch between things. What else do I need to do? I could run locally. You know what? I think I'm ready to stick with flydev. Okay. All right, so let's see. I'm just going to give it a practice run. It's going to be super rough, but this is how I did the first talk. I did a bunch of practice runs with no one listening, a couple practice runs with small groups, and then finally the day of the conference, I had the full-blown talk. All right, so let's kick it off. Let me get things arranged here. Okay, and then I think this will be the last window that needs to get thrown behind here. Sweet. Okay. Here we go. Welcome everybody. I'm here today. Welcome everybody. I'm here today to talk about WebAuthn and LiveView. So this is all about building a passwordless future using Phoenix applications. So my name is Owen Bickford. I am a real-time application lover. I am a web security enthusiast. Definitely not an expert, but my path to Elixir looks somewhat like this. I'm happy to chat more in the hallway if you want to talk about my history and how I've come to the place where we are today. And I want to start with the demo. So we're going to be talking about LiveView, but primarily about WebAuthn. And I want to demonstrate what we're talking about before you start seeing the explanations, so you can kind of understand, at least on the user side, how things are going to be working. So we're going to use my application that I've been prototyping lately. It's called LiveShowy. So this is running on the internet. You'll be able to sign in. You can actually go to LiveShowy, and let's try signing up as a new user. We're going to do that first. Now, I'll point out here, I'm sign up and log in. Every page on this application is a live view. So I do have live real-time validations happening. And so this is actually persisting users to the database whenever they're successfully registered. So if you don't want to participate and try this out, it's okay. But yeah, if you do sign up through the website, it's going to create a user entry. If you want to try it and tell me to delete it later, just let me know. So we'll do a valid email address, which is actually an invalid email address, but it's valid looking. And then I'm going to give it a username. Now, for registration with WebAuthn, you don't necessarily need to require email addresses. For LiveShowy, because I do intend to launch this with end users eventually. Email will be important for customer service, for technical support and that kind of issue, and maybe even account recovery and that kind of thing. But it's not actually going to be a requirement to use WebAuthn. So with WebAuthn, really, you'll probably want to use a username field. To be honest, I'm not sure at the moment whether that's actually required. But anyway, I've got a fake email address and a new username that I'm going to go ahead and use to register or sign up for an account here. So the browser is going to ask me whether I want to use an Android phone, a USB security key, or this device. And by the way, a USB security key would be something like this. It's a YubiKey. The one I have is USB-C. It can connect through NFC. There different connectors and form factors for YubiKey. But for today, I think the most fun one to use is actually the one built into the OS. So here I get to use Touch ID from my laptop. A bunch of magic just happened. We'll talk about that in a moment. And the application now has a user account for this username and this email. And it takes me to the user settings page. I would love to talk to you about what this application currently does and what it will be doing in the future, but that's not the subject of today's talk. So that was the registration piece. Now, if I log out and I want to come back to the browser, to this site later, I can give it the same username, and then you'll see here there's no password to create the account or to log in, but I can hit login. It will ask me for the fingerprint that I used before. So I did that, and it took me back and logged me into the site. So now I can access my settings, and that's all there is to it, really. The nice thing about WebAuthn is for the end user of your application, it's an extremely simple, or less, I should say, it can be an extremely simple procedure. You saw it's really fast, especially when you're using LiveView. So I'm glad the demo did not go up in flames. It helps to have a site running just on the internet with a reliable host. So before we get into WebAuthn details, I just want to get a baseline of the room. So I'm going to ask a handful of questions here. You can raise your hand. Actually, today we're going to do something a little bit different. I want, if the answer to so for any of these questions, If you want to answer yes, just clap one time. So first of all, have you ever used a password? Should hear a clap from the entire audience, right? That's how I'm going to know they're asleep. Have you ever reused a password? We'll probably hear a lot of claps there as well. Have you used a password manager? Software engineers, I've been expecting some decent claps there. And have you been pwned? Has your account been breached, or has someone gained your password without your approval? All right, so have you ever used or have you ever implemented basic authentications? Have you ever built an application that requires username and password? Should hear claps across the room. Have you ever implemented multi-factor authentication? There may be a handful of claps here. Have you implemented WebAuthn? This is kind of a separate thing. So multi-factor could mean like a text code or an Authenticator app. It could include WebAuthn, but these are kind of two separate concepts here. And then finally, is this your first time hearing about WebAuthn or passwordless authentication? So I expect I'll hear a few claps there as well. Cool. So to understand the value of WebAuthn, I think it's helpful to understand, just take a quick look at the history of passwords. This is not a deep dive. We're not really focusing on how to improve password security. We're looking at replacing passwords entirely. But with that being said, passwords, after some light Wikipedia searching, what I found was that passwords, some of the earliest instances of passwords actually come from the Roman army, where they would use wooden tablets for something called a watchword. I would imagine passwords in some kind of form had been used even before that, but this may be some of the first documented cases of passwords being used. So the Roman soldiers would receive tablets with a password inscribed, and at the end of the day, they would either pass them off to another soldier or return them back to the base. And then if any tablets were missing, they would know they had a password and they had a problem, like they had a leak, actually. Fast forward maybe a few hundred years, the first computer system that requires a password is at MIT, and it's something called the Compatible Time Sharing System, CTSS for short. And so it had a login command requiring a password, and that's 1961 at MIT. Just over a decade later, hashed passwords were introduced into the Unix system, and so there was some work being done before that, but that's, I think, where Unix started to use hashed passwords. Glossing over lots and lots of details here, but fast forwarding a little bit further, if you have implemented basic authentication in an application lately in the past few years, especially with Phoenix, you've probably come across a couple of different algorithms. The first one might be bcrypt, which dates back to, I think, 1999 when it was presented at Usenix. Argon 2, don't know anything about Argon 1 actually, but Argon 2 was the winner of the 2015 password hashing competition. So those are the two that we typically tend to use in our applications for regular passwords. And then just over the past year or two, we received a major improvement of quality of life for Phoenix developers with the Phoenix GenAuth mixed task. So this was initially kind of developed as a proof of concept from 2020 to 2021, and then it was merged into Phoenix in 1.6. And so I'm sure a lot of people here have used this command to generate authentication, templates, controllers, and everything within a Phoenix application in the past year or two. Cool. So that was passwords. What we want to focus on today is the future and how it's going to be nice for us and for our users. So WebAuthn is a kind of an abbreviation for, like, what it represents is the Web Authentication Api. So this is supported in modern browsers. It uses public key cryptography. And so basically what that means is your device has a public and private key pair, and some of like your public key gets signed and sent up to the server. More details on that in a moment. It's most commonly implemented as multi-factor authentication currently. So typically, if you're, typically this is kind of in addition to a username password on a site, you might see a prompt for like a fingerprint scanner or something like that. But I'm here to tell you that you can actually, like either today or in the very near future, you can start to replace passwords entirely in your applications. There will be edge cases, but you can start thinking at least about replacing passwords entirely in applications that you're building, especially greenfield applications. And the reason for that is there's a kind of an extension or some new kind of ways that WebAuthn is being adopted. So passkeys is kind of the new kind of the missing piece here. So passkeys are basically cross-device key management supported. So it's currently supported in Android, but it's also coming soon in iOS. And actually, 1Password has announced that they will be, they already have some maybe internal demos of using 1Password as your security device. So as of today, you can use your Android phone as a security key. You can, in the near future, use iOS as your security key. And then whenever you do that, your security key can be synced to your next device. So you don't necessarily have to kind of re-register every time you upgrade a phone or lose a phone. But what will be really cool is with 1Password, you can use your 1Password extension as an account as your security device. And then that will be really cool because then you won't be kind of locked into Android or iOS. And so I would imagine other services as well will start to incorporate that. Other password managers. So let's start to understand some of the terms that I'll be using when we look at WebAuthn. The first is registration. So this is creating a user account for a user, typically a human. Authentication is how you verify an existing user's identity. A challenge is a buffer of cryptographically random bytes generated on the server. Attestation provides a signed public key to be used in future authentication requests. Assertion is a signature created by the Authenticator upon successful identification and user consent. The relying party is the owner of the web application. In the code, it can also mean like the host or a couple of things like that. But at the end of the day, like the relying party in WebAuthn terms is like the owner or like maybe the business of the application. Then you have an authenticator. So this will be the device used to create and store credentials. So this could be YubiKey. It could be your actual phone or laptop device. Or it could be, in the near future, like I said, it could be 1Password or maybe LastPass. We'll hopefully be working on something similar as well. And then finally, and as far as terms, and this is not all the terms that there are in WebAuthn, but these are the ones that are maybe top of the list. So the client in this context is really the browser used to create, to request credentials from the authenticator. So I do think I'll probably be adding like some illustrations at some point because just to make sense of all those terms. So if you want to add WebAuthn to a Phoenix application, you probably want to start by shopping for existing code. You don't want to necessarily have to start from scratch. So you're going to start at hex PM, and you're going to probably notice if you're searching anytime in the near future, you're going to search and you're going to find WAX is the most, it's like the predominant WebAuthn package. There are a couple of others which seem to be in active development. They're not fully documented, pretty low download counts, but I would expect to see more development on those as well in the future. And then one piece of WebAuthn is like there's a lot of binary data that gets sent back and forth between the browser and the server. So one piece of that is CBOR. It's an acronym, and the definition has escaped me at the moment. Then we have the Web Authentication API. So this is supported in current versions of Chrome, Firefox, Edge, Safari, other Chromium-based browsers. Sadly, not supported by Internet Explorer, but really, that's okay. So now that you've seen a little bit about WebAuthn, let's talk about using WebAuthn in a LiveView application or in a LiveView part of your application. So the package that I'm using is Wax, just because it's pre-built, it's working. I initially started to kind of write my own WebAuthn code, but I'm happy that Wax exists so that I was able to get make progress a lot more quickly. But anyway, here, so the Wax documentation predates LiveView. I think it was written around the time that LiveView was maybe in early alpha or beta, but it looks like all the code there is using controllers and HTTP requests. You would store your challenge and a connection session. All of this happens in the Phoenix controller. In your template, you have an HTML form with some nested JavaScript, and then you're sending HTTP requests. Things are a little bit different in LiveView land. So in a LiveView, we're actually going to have separate events for challenges and attestation events. And those can be named however you want, but those are the types of events we're going to be responding to. We're going to store the challenge in our socket assigns, potentially. We're going to use JavaScript hooks instead of embedded JavaScript in the template. And there may be some other bullet points there. So let's take a look at some code when it comes to, WebAuthn. So we'll take a look. I've got a LiveBook here. So if you haven't ever used LiveBook, you'll hear about LiveBook all throughout the ElixirConf, but I really like LiveBook here because it helps me demonstrate the code. So, and we'll show you a more kind of advanced example code here, but these are examples of getting a registration challenge and an authentication challenge. So the first thing you need some options to be configured for a registration challenge. And again, registration is where you're signing up for an account or creating a new account for a user. And we're not going to probably get into the details of different types of attestation, but Wax accepts either none or direct options here. Whenever you're telling the browser that you want attestation of none, then basically it's not going to give you, it's going to give you just the key from the user, but it's not going to give you a lot of metadata you could use to track the user. There are some options for getting more anonymized data about the user from the browser, but tracking is not something, it's not a concern for me in my application. I would advise you to look into the MDN docs and maybe even the WebAuthn spec if you want to learn more about user tracking with attestation. Other than that, we've got the origin. For LiveBook, it's just localhost, but in the app, it's actually a little bit more complicated than that. We'll take a look in a moment. RPID is short for Relying Party ID. I'm letting Wax set that automatically. If I remember correctly, RPID is actually going to be the host that it's running from. Now, if I'm running this on a server somewhere, I want that to actually show the URL or like the domain that this credential is going to be used for. But anyway, we pass those options into this function for Wax, new registration challenge. And this is the data that it returns. So this is the challenge. We're going to store this challenge inside of the socket assigns. And then we're going to take some of this data, we're going to base 64 encode it and send it into the browser through a JavaScript hook. So we'll come back to that code in just a moment. You'll see that we have a timeout here. So this tells the browser that you can wait for the user to acknowledge and use a security key for up to this many, I think milliseconds. I think that would be 2 minutes. I think, I don't know, could be wrong there. We're not going to dig into every piece of data here, but you'll see what's important is the bytes. So these are the bytes. These are random bytes that are generated. They get sent and used by the browser to generate unique key pair from the authenticator device. So what's important to say about that is that you're not, whenever you use, like say you have a single USB YubiKey, you can use this across multiple sites, and each site gets a separate public key or a public-private key pair. So then whenever the user comes back, and there will be some additional code here for the data that we're sending or getting back from the JavaScript hook, but for now we'll look at the authentication challenge. So whenever you're creating an authentication challenge, you need to provide a list of allowed credentials. So this only happens for an existing user. So your user in the database, you're going to store probably in a separate table. You're going to have like a user keys table. That's how I've built mine. And I'll take the key ID and then the public key, and those are passed into a map here. Pass in the same options that we had before, and then so the allowed credentials and the options are passed into an authentication challenge. And by the way, allowed credentials could be like multiple. So like if I have 3 or 4 different devices associated with my account, allowed credentials should include all of those devices. So for each key, like that should show up in the map with the key and the value in the map. And key, like the word key here is overloaded because in a map you have a key value, but we're talking about security keys. So forgive me for having to deal with these overloaded terms. But those will be passed into the browser so the browser can know, do we have like this public key? Do I have any security devices that match? If so, it will prompt me to use that device. Otherwise, it will show me a message that I don't have any devices registered, or it will ask me to use like a USB key, because it may not, like if it's not a Touch ID public key, then it's going to maybe let me try to use a different security key. Anyway, so the rest of this looks a lot like the registration challenge. You'll see that user verification is preferred. RPID and origin are the same as they were in registration. We have some trusted attestation types, and then we have authenticator statuses. So a lot of stuff from FIDO, and probably don't have time to get into the weeds on that. So now we can take a look at some more code. Do I have my... I need my notes. Okay. So now we'll take a look at the actual code for my application. So we're going to start with sign up. So we have a form defined here in this LiveView. I'm using surface components. So I've got a form component here. It uses a handle WebAuthn Phoenix hook that I've defined. So I've got a little bit of custom JavaScript for this application, and it's used for currently primarily for WebAuthn, but also we'll be using many more hooks for web MIDI stuff and maybe even audio and more fun stuff like that. Anyway, what we're talking about is WebAuthn. So the field accepts the email username for registration, and then also, yeah, so whenever it submits, it just has a submit event that will be triggered. And so whenever the user submits, basically trying to say, I want to sign up, then we're going to create a registration challenge right here. So we get the origin. So this is actually one kind of fun piece here. Helpers. So I have a dedicated function for, so developing WebAuthn stuff locally is a little bit tricky because of Safari, if I remember correctly. So I have a helper function here that will either use, so in development mode, it will take the socket's host URI and then return the scheme and the host here. That's important because in Safari, it will not at least in the current version that I was testing it on, Safari would not allow me to actually use WebAuthn on localhost. I had to, like, I can do that in Chrome, but in Safari, I had to actually run like an ngrok server. And then I had to do this so that that ngrok URL would show up as the host URI. Otherwise, if we're running in production, then basically we're just going to take the endpoint URL. So that's the get origin helper there. And so in a nutshell, this is just going to be a URL. So HTTPS once it's in production. Otherwise, it's going to be HTTP if you're running locally and opening it in Chrome. Now, currently for the live stream, I've got this. I'm putting the challenge in the process, but I will be updating this to put the challenge inside of the socket assigns. I think either way is acceptable, but I think just to be more, I think this is kind of an anti-pattern to put things into a process memory instead of just using the socket assign. So I just want to be idiomatic whenever I'm writing my Phoenix live views. Anyway, whenever you hit submit, we do a no reply and we're pushing an event to the socket. So I'm giving an app name. I'm giving it the attestation from the challenge. So what was that? We have attestation of none. We have the challenge bytes, so that random binary data. We're base 64 encoding it, and we're not going to pad that base 64 string. We're going to take the challenge RPID. Now, again, I've told Wax to just set that for me automatically, but in this case, it's going to be localhost. Once it's in production, it should be whatever URL or whatever domain for the site. Then the user, I'm passing in the user object here, or the user map, which is just a username and email. And finally, passing in user verification. So that is like a string called preferred. Now, if the change set has errors, I'll render an error message. That's all that's happening there. So at that point, the server has presented a challenge to the browser through the LiveView socket. And I'm using this LiveView hook, this JavaScript hook here. So this hook is called handle WebAuthn. You saw this in the form. And let's see, I'm going to collapse a couple things here. So on mount, I've got some helpers for base 64 encoding and decoding. But here I've got an abort controller, so I can cancel requests if I need to. I have a user token. We're not going to pay too much attention to user token. That's kind of a separate concern here. But I will report back to the LiveView whether WebAuthn is supported. So if a user happens to encounter this site and they don't have WebAuthn support, then I want to render a message on the page because the user is going to need to know that they can't actually use the site without WebAuthn. So that should hopefully redirect them to either upgrade their browser or use something that supports it. And the messaging could probably be better on that later. Other than that, I've got listener options, which is basically taking the signal from the controller that I've assigned. And this only, all these listeners only get attached, and this event only gets pushed if the navigator object has a credentials key. I think it might even be safer to say credentials in navigator, like in the JavaScript here, but this is okay. It's worked for me so far. So as long as the client actually does support WebAuthn through navigator credentials, we're going to attach a handful of event listeners. And I could probably improve this. Like right now, everything's kind of lumped into one webhook, but I probably could separate this into like a registration webhook and then a authentication webhook. But for now, they're all in one place. So I will attach a listener for registration challenge, login challenge, store token, and clear token. So the registration challenge uses whatever data is provided whenever that event is triggered. So this is whenever I push registration challenge here. So on the server, I'm pushing an event called registration challenge. The JavaScript hook sees it as this Phoenix kind of prefix. And then it takes whatever data comes from that and passes it into this registration challenge function, and then passes along some listener options so it can be canceled if it needs to be. Then here inside of the registration challenge, I have a try catch and a lot of code, but basically what I'm doing is I'm taking the challenge, destructuring the bits that I care about, encoding and decoding things so they're formatted for creating the public key. So the challenge buffer shows up here. We've got the app name and the RP ID showing up in the relying party key. The user has a random ID generated on the client, which is not used in the server. This is kind of a separate ID just for the client. And then we give it a username from the user. Other than that, we have public key cred params. There may be other options, but these are the ones that I needed for WebAuthn. We have a timeout here of 60 seconds. I think that's 60,000 milliseconds. So a minute, in other words. And now that I think about it, I think in the server side, this timeout was maybe not in use. Anyway, so we have our attestation that was provided by the server as well. So you can see a couple of these values are hard-coded. Some of these are generated on the client, but then some of these are actually provided from the server. So that's one lesson I learned, was provide as much configuration for WebAuthn as you can, or as it makes sense to do from the server instead of from the client. So that includes user verification coming from the basically that's being set by Wax and passed into the WebSocket through this hook. So that public key object will be used on this navigator credentials.create function. So that uses the public key object, and then we're destructuring the raw ID, the response, and the type from this create function. And I'm using an async function here so I can kind of cleanly just wait for the results and not have to deal with promises. And then I'm kind of destructuring a few more things here. So out of the response comes the attestation object and the client data JSON. And then these need to be converted back to base64 pieces so that they can be sent across the wire, except for the client data. The client data actually just shows up as an array. So all of that information gets pushed back up to the server as an event called registration credentials. And then the object here is just using the same key for each of these value names. So back in the signup LiveView, that registration credentials event shows up here. We get our attestation 64, we get our client data, which is not encoded, we get our raw ID 64, and then we get our public key type. So this is going to make sure that we're only accepting credentials which are of the type public key. So this is a presumption that I'm making here, that this is the only type that I want to support or that would be valid. I could be wrong about that, but we'll revisit that later. By the way, I'm hoping to kind of run some of this by maybe a security expert before the actual conference, just to make sure, check myself before I wreck myself is what I want to do. So then I've also got the user data will just come out of the changes on the chain set. So it's like the username and email. And then I basically use all of that. So I decode the attestation. I create a Wax challenge. So this is making sure that the challenge, I'm pulling this out of the process. Actually, this will be a socket assigned. So that's going to be updated. After that, I'm using wax.register to take that attestation, the client data, and the challenge and trying to register a user. So as long as all of that data is valid, I will have Authenticator data and some additional data that gets ignored. And from that, you do a little bit further breakdown here. So we have a key ID, public key, and that's user key. Oh, right. So I'm just kind of structuring things here. So I take the Authenticator data and I kind of pluck some pattern matching some things out of it. Then I'm building this user key object, and then I'm calling my accounts context to register the user with the key. So all of this is happening within a with statement just to allow me to catch errors and render, errors that might have happened throughout this process. After that, I've got a token that gets generated, and then it gets base64 encoded. I put the user into the nav bar, because at this point they're signed in. Then what else? I push an event to store the token. I push a flash that registration was successful after I clear the flash. There's some error handling here. The user token. Okay, so then once the user token is stored, so this is another piece of the webhook, also again conflated with WebAuthn stuff. So if I receive an event called store token, then I call this function, which just puts it into session storage. And I think, if I remember correctly, what that's doing is it's allowing the user to come back to the page, even if so they can stay logged in as long as they haven't closed the browser or cleared cache and cookies, basically. So anyway, so once the token has been stored, basically maybe a couple milliseconds, we decode the token. We make sure that we're basically just kind of safeguarding that the token was valid, it hasn't been tampered with by the client in any way. And then as long as we get a valid user with that token, that means it was the correct token. It wasn't tampered with from the client side. Once we do that, then we redirect to user settings. So we've got a helper function for that. We handle some errors, handle errors, and then we handle any kind of unhandled errors and messages. And the login process looks a lot the same. What we do is we will, whenever the user submits the form, we will generate our challenge options. We will assert that a user can be found with that username, so that we're pattern matching on a valid user here. Otherwise, there's no user, then we show an error message. If we have a valid user with that username, we want to make sure we're getting the user keys, so we can take each of key ID and public key value, put those into a list of tuples. Those are passed into the authentication challenge. Those are called allowed credentials. We also pass in the credential options. We're putting the challenge into the process memory. That'll be a socket assigned later. But then we're taking the key IDs from that map of allowed credentials. And then we're telling the Phoenix JavaScript hook that we have a login challenge here. So we'll take a look at that in a second. We're passing the attestation, the base64 encoded challenge, the allowed key IDs, and then the user verification. So again, that's actually kind of predefined by Wax. I'm not overriding it. So that is the login challenge. Let's take a look at the JavaScript here. So here we have our event listener for login challenges, which receive data and then pass that into this login challenge function. So here we're just kind of destructuring the data that came from the from the socket message. We are mapping over the key IDs. And so that's a list of base 64 encoded key IDs. So we're converting that to an array. We're returning, for each key ID, we're returning the buffer. We're telling it it's a public key. And then we're allowing these transports. So we'll allow USB, Bluetooth Low Energy, NFC, or internal. So internal is like the OS, like Touch ID, Face ID, that kind of thing. Hello, Windows Hello. These others are more like cross-platform options. So we're allowing those, and then we kind of decode the challenge. Then we have another public key kind of object here that we're defining. Again, it will wait up to a minute for the user to validate with their whatever device they're using. We will run navigator.credentials.get. So earlier we called create. This time we're calling get. And as long as that is successful, we'll have a response here that we're destructuring as the raw ID, type, and response. Otherwise, we're catching errors and pushing those back up to the server. Then we're kind of destructuring the response out of that. And this looks familiar by now, I hope. So we're kind of reformatting that data similar to how we did during registration. And then we're pushing an authenticate object back up to the server. So here we have an authenticate event handler. So it takes all of this data again. Most of these are base 64 encoded. And then we're just going through another process where we're decoding the data. What else? We are authenticating the user with all of this data that was provided. We are validating that we can get the user by their raw ID, making sure that we can get the user session token, making sure that that can be encoded. And then we're setting the user in the nav bar. We're updating the user key. We're updating there's a column called last used. So I'm keeping a record of like when the key was used. So like, I might want to audit at some point, like keys that have not been used within a year, 10 years, 5 years, or whatever. I might want to email the user and ask them, hey, is this a problem? Do you want to delete this? Do you have any memories about this key? I don't know. And then, so then we have another event here. We tell the client to store the token. We've seen that just a few minutes ago, so I won't go through that again. But we're sending the token, and we're saying that we're successfully connected. And once the token is stored, we are validating that the token was successfully and correctly stored and not manipulated again. As I'm walking through this, I'm thinking I might actually want to do like setting the user and doing the user key updated. I might want to move that into this successful token storage handler, but that's a topic for another day. So that's the code that I wanted to show you for WebAuthn and LiveView. Hopefully, it wasn't. I mean, it was complicated. There's, it's not exactly a walk in the park, but hopefully, whenever we do this demo again, with everything you've seen so far, hopefully this will make things will start clicking. So I'm going to go ahead and register again as a different user. And so I'm going to sign up. So again, like I showed you earlier, I could use a USB key. I can use my on-device credentials, or I could use an Android phone if I had one. In the future, if I'm using Safari, I'll have options here for using keychain to store this as well. But I'm going to use this device, use my Touch ID, redirect it back to settings. You saw that was super fast, and that's running over the internet here. And pretend we're on conference Wi-Fi. So now I've logged out, and I'll log back in with the same username. And just to show you, oh, that's not what I wanted. So I'm going to try to open Developer Tools. Get this back to a good size here. I think, which shortcut is it? There we go. So let's see. I'm going to refresh this page so you can see. I think we'll see the socket events. Okay, so I'm going to do 4, 5, 6, 7. Of course, you'll see change events because this is a change set. It's validating. Well, it may not actually be validating on the login page. It was validating more on the sign up page because we want to make sure you're giving us an unused email and username. But for here, I've got a username, so I'm going to hit login. You saw a couple events happening down here. I'm going to go ahead and use the password again, and this may, yeah, that went away because it, redirected. So anyway, I did it again. Hit the wrong shortcut. So that was the registration and login process. And again, this is what the data looks like for registration and authentication challenges. We'll have more examples of code objects being generated from the JavaScript side later. So just to recap what we've seen today, we're looking at WebAuthn, which is the Web Authentication Api. It's supported in modern browsers, so just I think almost everything aside from Internet Explorer and some of the more obscure mobile browsers. Mobile browsers. So it uses public key cryptography, which is very secure, very hard to hack, if possible even. And public key cryptography is basically public-private key pairs. Again, as of today, most people are using it for multi-factor authentication, but it can be used to replace passwords in some, maybe most cases. And passkeys are going to help us use our credential even after we replace a device. So that will be extremely handy. Support for passkeys is coming soon to iOS and 1Password. And wrapping up here, I just want to give my thanks to everyone who has collaborated with me over the past year. Anyone who had thoughts about WebAuthn or helped give me feedback. And if you want to find more about me or what I'm working on, these are the places you can find me. Ta-da, that's the talk. So, cool. I think that's going to be a fun little talk. Hopefully people are not extremely bored to tears. But yeah, I've gone now almost 3 hours. I think I'm going to call it a day. Been standing for an hour, that's good. So after kind of doing a talk there, I'm also a little bit feeling hoarse. But yeah, so if you've been watching, if you have any feedback or thoughts, let me know. Hit me up on Twitter, I guess, at Owen Bickford. I will be running some of this code by some folks that I know in the security space, because I want to make sure I'm getting this right. And then kind of go from there. So I do want to say before I close the stream today, next weekend, so the weekend of the 20th, I think it would be on the 24th of July, I will not be live streaming. I will be busy, maybe driving somewhere, so I guess take your time. It's not like anyone's watching this live anyway, so anyway, there won't be a live stream probably at all next week, because I will be away from keyboard for multiple days. So really looking forward to that. I'm sure I'll be desperate to get back to a keyboard and to the computer by the time it's over, but looking forward to having some time out more in nature and that kind of thing. So thanks again for sticking around and watching. If you want to find out more about what I'm doing, probably the best place to do that is going to be on Twitter. So yeah, my Twitter is at Owen Bickford. You can find some of the code that I work on at LiveShowy on GitHub. I do have the initial prototype for Live Showy, the like local Wi-Fi version, publicly available on my GitHub. So yeah, I will catch you again on the live stream in a couple of weeks. And if you're going to ElixirConf, I look forward to seeing you there. Definitely let me know if you watch the live stream. Anyway, thank you. Have a great weekend and a great week.